There are two blocks of masses M, 2 kg, means 2 kg, and 2M, 4 kg are placed on triangular wedge means of a massless and inextensible string over a frictionless fixed pulley. Surface of contact between the masses and wedge is frictionless. So note of counting the frictional force. The wedge makes 45 degree with the horizontal on both sides as shown in the figure. Find the tension in the string. So both are equal angle, M and 2M, no frictional force. So no doubt 2M, which is greater than M, will make a sliding effect downward so that M starts sliding up. Now if you count M, it's pulled up by the string with a force called tension in the string. Now the weight of this mass is acting vertically downward. If you resolve that into components, we already learned there is a horizontal component and vertical component normally when we resolve. But here when we resolve parallel to the surface and perpendicular to the surface, we get a component downward as mg sin theta. If this part is not clear, how mg sin theta comes down, we'll explain at the end of the question. So now the component against tension downward is mg into sin theta. So here mg sin 45. Same way here, this mass is also pulled up by tension, string, same tension, one string. Same string between M and 2M, so tension will be same. Now there will be a downward force against tension. It will be 2 mg sin theta because mass is 2m. So 2 mg sin 45. 2 mg sin 45 is greater than mg sin 45. So the object will start sliding down with 2m downward and m upward. So the acceleration of 2m will be downward and will be upward. That means if you consider m, tension force is greater than mg sin 45. If you consider 2m, 2 mg sin 45 is greater than tension because acceleration always happens in the direction of the greater force. The acceleration is downward, this is a greater force. The acceleration is upward, tension is the greater force. Now you consider mass m, the net force when there are two forces acting in the opposite direction will be greater force minus the smaller force. The net force on mass m, F1, equal to greater force T minus smaller force mg sin 45. Now force is always mass into acceleration. So mass is m, acceleration is a, we don't know, we are calculating. So the net force is mass into acceleration. So ma equal to T minus mg sin 45. Question number 1. Now if you count 2m, here greater force is 2 mg sin 45. So the net force will be greater force 2 mg sin 45 minus the less force T. So F2 equal to 2 mg sin 45 minus T. Here also the net force is mass into acceleration. So 2m into A. So 2ma equal to 2 mg sin 45 minus T. Equation number 2. Here we don't want to count the frictional force because they told the surface is frictionless. Now if you see the equation, right hand side we have T minus mg sin 45. Here right hand side is 2 mg sin 45 and minus T. Since plus T and minus T are there on the right side, if you add equation 1 and 2, the right hand side T and minus T get cancelled. The left hand side is ma for the first equation, 2ma for the second equation. So LHS plus LHS give you 3ma. T and minus T get cancelled. Minus mg sin 45 plus 2 mg sin 45 add up to give minus and plus, so 2 mg sin 45 minus mg sin 45 will be just mg sin 45. Now the mass get cancelled on both sides. You can get 3i equal to g, which is 10 taken approximately, sin 45 is 1 by root. So acceleration will be 10 by 3 root. Root is 1.414. We estimate this value is coming approximately 2.4 meter per second square. Not meter per second, meter per second square. Now you got acceleration. For finding the tension, you can go back to equation number 1. So according to equation number 1, tension will be, you can take mg sin 45 left hand side. So tension will be equal to ma plus mg sin 45. Now m is 2 kg, a is 2.4. So 2 into 2.4 plus m is 2, g is approximately 10, sin 45 is 1 by root. So 2 into 2.4 will be 4.8, 20 by sin 45 is 1 by root. Root is 1.414. We estimate that value will be 4.8 plus 20 by 1.414 will be 14.14. So be coming as ultimately 4.8 plus 14.14, which will be 18.94. So the total tension will be 18.94 meters.